Okay, so right now we're going to start with the title of the paper, so let's title it so we know when we're referring to this what we're looking at. Atoms. We're looking at pluses, minuses, and neutrals, and that will reveal itself as we go through the lecture today. And it's always good to write the date, so if you lose stuff, or you have to come back and refer to things because you're absent, etc., then it's a good idea to always have the date. And the page numbers are always nice. Again, this stuff just helps keep you organized. So let's title it. If you can't see in the back, you're going to have to raise your hand so I know, and I'll zoom it in a little bit further for you. Go a little bit. Yeah. There we go. All right. So the first thing we're going to do is define the law of conservation. There's a couple different laws of conservation. There's law of conservation of energy, and the ones we're going to talk today about is law of conservation of mass or matter. You'll see them both ways. So we're going to talk about the law of conservation of mass, or sometimes you'll see it as matter. And hopefully this will start ringing a bell as I go through my notes with you. Okay, what this states is that matter or mass cannot be created or destroyed it can change form. So a state of matter from a solid to a liquid to a gas. So it can change form and move from place to place. There is a fixed amount of mass or matter in the universe. So that's the law of conservation of mass, or the law of conservation of matter. So we never get stuff, we never lose stuff, but we can change what it bonds with, or the states of matter it changes. What is matter? Let's define that. Okay, matter has mass and volume, which means it can be measured in we measure mass in what? Units of grams, okay, that's the metric unit. And we measure volume in liters. What else? There's one more.
Length and meters.
Meters, what? Length times width times height. So it's meters cubed. Cubed. Let's do that. Length times width times height. That's three things. 1, 2, 3, cubed. So liters, we measure volume. That's liquid. Meters cubed is solid. Cubed. One of the things that you guys don't do a lot, make a lot of mistakes with, is following appropriate sequence from one statement to the next. So I want to make sure that I have this opportunity to show you what I mean. So when I say that matter has mass and volume, and I give examples, I need to go in that sequence. So I said it has mass. So when I said, which means it can be measured in, I need to put it in that sequence. Mass is measured in grams, so that needs to be listed first because that links those two together. So I know now when I see grams, I'm talking about mass, not volume. So when I then put the second item, volume, I'm going to list examples of that next, which is liters and meters. So make sure that when a question is asking for an answer of grams and liters, your first answer is grams and your second answer is liters or whatever. Follow the sequence. Okay, all matter has, well, we know it has mass. And we know it has what? Volume. Ooh, what's that? Density. So now we know that all matter also has density. So we can calculate density because all matter has mass and volume. So to try to remember that, we talked about that shortcut, mass divided by volume. If you say, I love density, I heart density, you split that up, that top of that heart starts to look like an M and the bottom a V. So that shows you you've got I, heart is mass divided by volume. Okay? So let's say that someone comes up to me and gives me this nice huge chunk of gold. It says it's gold. I don't know. I don't even know that person. Not sure. Okay? But I want it to be gold because it would be worth a lot of money. Or not. It could be a joke. So what I can do is, because this is matter, it has mass and it has volume, I'm going to calculate the density of this. So I'm going to go get the mass, get the volume, get my density. I'll get a number. Everything on the periodic table, all the atoms, have a specific density per atom. So if you have a whole bunch of atoms that are the same, that's an element. So if you have an element, it's going to have a specific density. So you do have periodic tables, not this one, but you do have periodic tables that'll list out the element and also the density. So the density is going to be specific to each element. So I can do this very easy thing. It doesn't take much. I calculate my density, and I go and I look up gold, and we'll say whatever the gold's density is. And I'll check it against what I got. Oh my gosh, it's gold, it's a pure sample, I'm happy, I'm gonna go spend some money, okay? Now, if it's really close to that, and I still think it's kind of gold, but the density is not gonna be perfect, because maybe there's some impurities in there, maybe there's some quartz in there, or some sand in there, or whatever, then I have to do a whole other process to make it pure. But if it's a pure sample of whatever, any of these, it'll have a very specific signature density, and we can use that to find out that particular atom or element. Okay? So that's one reason why density is pretty valuable when we're starting to work with atoms and elements. And minerals, we'll lead into minerals. So what is an atom? Let's do that one next. Okay, an atom is the smallest form. It's so big. is the smallest form of matter that keeps its properties and characteristics. So if you have something that's pure, let's say this is a pure sample. This would be an element, okay? There's a whole bunch in here of that pure substance, whatever it is. Now, if I break it, and it goes into a bunch of pieces, and I take a small piece of that, is a small piece still made up of those atoms? Yeah. Hit it again. Smaller pieces. Is that still made up of a whole bunch of atoms? Yeah. Till you get down to the really, really tiny piece that if you pulled it apart, it would no longer be this. It would be something totally different. So once you get to that very small portion that it can no longer be divided and maintain its characteristics and properties, then the point right before that, it's still an atom. Okay? So they get very, very small. Now if we look at an element, so that's the next thing, an element. We're going to go ahead and give a more scientific definition, and then we're going to break it down into a little bit simpler terms. So here's your element definition. An element is a pure substance that cannot be separated into smaller substances by a chemical process. So basically, what that's saying is an element is more than one atom that are the same. So if I have one atom of gold, it's going to be super tiny, you can't even see it. But if I had a huge sample of gold, that would be an element. Okay, it's more than one atom. They're all the same. They're all gold. But there's a whole bunch of them now. So that's the elemental form. So even simpler, an atom, you can think of it as singular, and an element as plural. Picture, there's an atom. Now, these are going to be exactly the same. So it's exactly the same. I have an atom. I have two things that are exactly the same. Oh, it's an element now. Okay? So if you have exactly the same, you can have a whole bunch of atoms together to make up an element. It's still an element. And these are all the same size. Pretend they're all exactly the same. Okay, again, whole bunch of atoms. They're exactly the same, but now they're pushed together and bound together is an element. Okay? Okay, we're going to go to our second page, which is where it starts to get really fun. Is most of this review for you guys? Okay. Yeah. Okay, here we go. You can. It's up to you. Yep. Okay, the next page we're going to go ahead and put number 72 again. I like that. And then I'm going to go ahead and title it. We're going to look at subatomic particles. We're going to look at their charge. And then we're going to add... Oh, give me 1 second. I will unblur it. And then we're going to add interesting notes about each one. There you go. So subatomic particles, charges, and notes to explain them. The first subatomic particle we're going to talk about is the proton. What's the charge? Very nice. Interesting notes. Here we go. So the atomic number is the number of protons. In that atom. Okay? So, let me grab a periodic table. Question?
Are you doing plus charge? Is that where the plus sign is?
Yeah, the charge is positive. If you're not sure what plus is, go ahead and write under it positive so you make sure you know. Okay. What does that mean? Okay, what's it mean? Let's look at our example here. Every periodic table will have a key. And they're a little bit different sometimes. They'll have things put in different spots. So you need to kind of orient yourself with each periodic table. On this one, it says the element names on top, mercury. The atomic number is the next one down. That's 80 for mercury. The symbol is Hg. And the average mass is 200.59. So if we look at this example, this key, what is the number of protons in mercury? 80, right there. Atomic number is the number of protons. Atomic number of protons, got it, 80. Okay? So when you have that, so let's try a different one. Let's try oxygen. So oxygen's right here. How many protons are in oxygen? 8. Nice. So oxygen equals 8 protons. What I'm going to do is I'm going to use this periodic chart a lot, and I might not have to reference my notes. It's just easier if I have everything on the same page. So I'm going to write some little notes to myself to help myself out. So right next to atomic number, I'm going to write equals number of protons. So now that I know 80, the atomic number is the number of protons, and mercury is 80. So to help myself just get that, I'm going to practice a little bit. So I'm going to be like, boron, 5 is the atomic number. Boron has 5 protons. Carbon, atomic number 6, 6 protons. I'm going to go crazy and just pick one out of the blue here. Oh, let's see, 10. 50 is the atomic number. 50 protons, okay? So you just kind of repeat that a little bit. A lot of us like to practice at things to get better, but somehow think we don't need to practice to learn things. So make sure you're doing some practicing. You can talk to yourself at home if you want. Okay? So let's move on. This is the kicker here with protons, and it'll try to get you every time. So make sure here you know this. Protons. Never, ever, never, 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 ever change. Wow, that must be important.
Should I write it all
That's
down?
probably not that good.
You could.
Okay, I will.
So when we're looking at oxygen having 8 protons, oxygen, if it has 8 protons, it's oxygen. If it doesn't, it's not oxygen. It is totally, totally different. Okay? So if we do that, let's look at oxygen right here. Oxygen has 8 protons. If it was oxygen and lost a proton, it's not oxygen anymore. It's nitrogen, which is totally different than oxygen. If it somehow ran into and grabbed another proton from another atom, it would become fluorine, which it doesn't. Oxygen and fluorine, totally different. So the number of protons never changes. It will not maintain the same properties and characteristics if the number of protons changes. It will be wildly different. Okay? So make sure you remember that. Where are the protons found?
The nucleus.
Thank you. Protons found in the nucleus. Let's draw. So usually when you look at a model or drawing, you'll see the circle in the middle, and sometimes you'll see these orbitals or clouds on the outside. So the nucleus is that middle portion right there. And the protons are in there. So I'm going to put some protons in there. Now, tell me what atom is that I drew? Boron. So we counted the little positives. 1, 2, 3, 4, 5. I find the atomic number 5. I know it's the same number of protons. Read the little name there. Boron. Awesome. Good job. Okay. Oh, one last thing. Protons have mass. And then we're done with protons. Next, I would like to introduce the electron. So we're basically going to kind of go through the same thing. So we have now the electron, and the charge is negative. You can write that down. So let's have some interesting notes. Okay, all atoms on the periodic table are neutral or stable. It means the same thing, which means their net charge is 0 So how do we determine that? You're going to take the number of protons and that equals the number of electrons. And that means we're going to get a net charge of 0. Now, we do have electrons can change. You can get some, they can give some away. But on the periodic table, they're all in a stable form. So if we have magnesium, with your atomic number of 12 and your atomic mass down here, How many electrons are in magnesium? 12. Okay, so if you have, we know the atomic number is protons. If we have 12 positive charges and we need to get to a 0, how many negatives do we need to add to cancel those out? 12. So now what we're saying is we have 12 protons and 12 electrons in the stable form of that atom, which is listed on the periodic table.
So would magnesium look the same as the boron, but with just 12 of the positives?
Right, so if you're looking at boron, which is 5, okay, so let's look at that. So if we look at boron, we know that there's 5 protons, right?
Yeah.
And how many negatives do you need to cancel that 5 out?
5.
Right. There you go. So you've got 5 protons and 5 electrons. What do you have in phosphorus? Garrett?
Huh?
What do you got? Phosphorus?
Yeah, 15.
15 watts?
15 purple.
And how many electrons?
15.
There you go. So now we know that on the periodic table, the atomic number tells us the number of protons. It also tells us the number of electrons. I'm going to add that. Okay. So add that to your periodic table. Let's draw it. So we have the nucleus, and we have these clouds or orbitals. Where are the electrons found? The clouds. I'm going to draw some electrons on here. You're going to tell me which element I have. We're going to give a second. Okay, so what element? Oxygen. So what we did is we counted the negatives. Electrons, 1, 2, 3, 4, 5, 6, 7, 8. It's in a stable form. It's on the periodic table. It's going to be the same as the protons, same as the atomic number, 8. I'm going to find it, 8, oxygen. Nice.
So wait. Question.
Yep.
When you did 5 for boron,
Yep.
why didn't you put it on the little top thingies?
Because I'm just doing one example.
Oh,
Yeah. That was just more of a verbal.
okay. So if you were actually trying to draw, would you do it both?
Right. So if I was actually trying to draw boron, I would do this. I would draw my nucleus. I know there's 5 protons. 1, 2, 3, 4, 5. And then I would put on some clouds here. And then I would put 5 electrons out there. 1, 2, 3, 4, 5. And that would be boron. And then we'll get to then how many neutrons are there. So that's going to be our next one. But we have one last little note. Okay? So when we're talking about electrons, a lot of times you'll hear that they have no charge. That's not true. They're matter. Okay? So what we're going to say is they barely, emphasize barely, have mass. It's almost 0. I mean, you need tons and tons and tons and tons, 10 times the whatever's to register the mass compared to protons and neutrons. So we'll say that they barely have mass. And that's why a lot of times you'll see or hear people say that electrons don't have mass. But they do, just a teeny tiny bit. So the last one we're going to talk about is the neutron. Neutron. And the charge is neutral. I love that because neutron and neutral sound a lot alike. Okay, so this one is the one that can mess you up a little bit. So concentrate as we go through these notes. To find the number of neutrons, this is what we do. You're going to take the atomic mass, and you're going to subtract the number of protons. And that's going to give you the number of neutrons. Okay? Oops, let me move that over. So we're going to do zinc. So here we have zinc. We have 30 as the atomic number and 65.39 as the atomic mass. Following that little formula, take the atomic mass and then subtract the protons to give you neutrons. I want you to go ahead and find the number of neutrons for zinc. If you need a calculator because you can't do that by hand, then at least write out the numbers and where they go. You should be able to do this. You have the answer already? Okay, so this is a fairly simple problem, but a lot of times in story problems or where they give you a lot of information, they're like, I don't know what's going on, I'm confused. So the more difficult it gets, the harder it is sometimes to plug the numbers into the right spot. So if you find that, I really like highlighters because they help me really focus. So I'm going to spend some time figuring out what number it goes with what's being asked. So that's why I did the highlighter on this. So I'm going to take the atomic mass, which is found here, and it goes on top. So I'm going to plug that number in, 65.39. And then I'm going to subtract the number of protons, which is this number right here. So I'm going to subtract 30. And then I'm going to do the math. So I'm going to bring down the 9, bring down the 3, add the decimal, bring down the 5, and add the 3. So I've got 35.39. So for these examples that you guys have, you can go ahead and just round. Here we go, 35. So we're going to say there's 35 neutrons in zinc. Now, when you're looking at the periodic table, the electrons can change, okay, from some of the examples you're given. So sometimes we have ions. So when you compare electrons from a story problem to the periodic table, they can be different. That's an ion. If you have a number of neutrons that are different than what's on the periodic table, it's an isotope. It happens. You never have a difference of protons because protons never change. So sometimes you'll see differences in electrons and neutrons, but never protons. Okay? So let's write down, where is that neutron? Where do we find neutrons?
The nucleus.
The nucleus, another neutron, neutral nucleus. Very nice. So I'm going to just go ahead and signify these with zeros. So what element is that? I drew 7 circles, 7 neutrons in the nucleus. What do we got? Okay, we have nitrogen because 14 minus 7 is
7.
Thank you. So that's nitrogen. Neutrons have mass. Okay? Nice. I'll go ahead and hand out your homework.